All right, let's talk a little bit about how we might use this stuff. I'll give you a little foreshadowing of what's going to go on maybe in your other courses or whatnot. Or even a little bit of a foreshadowing of what's going to go on like in your deck design problem. Okay? So let's talk a little bit about design and how this whole concept of stress is sort of applied to it. We've already sort of briefly mentioned it, but let's go a little bit more in detail. First thing that I'll tell you in design is that there's different design philosophies. There's different design methods. Sometimes you're using a material that has its own design method. The code will say, hey, for concrete, use this method. Or maybe in steel might say you can either use this method or this method. Okay? So I'm not going to talk about design relative to any particular type of material. I'll just talk about design sort of in general. But you should realize that there's different methods out there. Okay? One method that's out there that's really one of the oldest methods is what they call allowable stress design. And I'm not going to talk about any particular material that might use this, but I'll just talk about this design method because it's a really easy method to comprehend. This method basically says this. If you can calculate your actual stress and the code that you might be using, or somebody, maybe your teacher, gives you a stress level to stay at or under, then you're going to be okay. We call that stress level that somebody might give you, like a code or a manufacturer, or even here in school it might be your teacher. We call that stress an allowable stress. What you're allowed to have on it. Well, if I'm allowed 10,000 psi of stress, and I'm designing my member such that it's at or under 10,000 psi of stress, I guess my member must be okay, or should be okay. That's allowable stress design. It's real easy to understand. Okay? Biggest thing people have trouble with is they say, well, where do you get allowable stress at? Well, allowable stress, like I said, is given by a code, or given by an expert, or given by a manufacturer. Okay? You might get into, designing like foundations. And how you're going to get the allowable stress is the soils report that the geotechnical engineer gives you will say, hey, for this type of soil, the maximum or the allowable bearing pressure, bearing stress is 4,000 pounds per square foot. Okay? You might be using some like embedment that's being embedded in the concrete. Maybe like a lifting hook or something like that. But they're embedding into like a concrete, precast concrete slab. And you might say, well, geez, Pete, I wonder how much that lifting hook can hold. And you could probably go to a manufacturer's literature, a table, a reference that the manufacturers have, and you probably get into a table and I'll say, hey, for this lifting hook, XG 7700, it will have an allowable stress of 7,000 psi, or something like that. Could get into a code or a design specification. Okay, but that's right now. It's not really our problem where allowable comes from. But believe me, allowable. You're familiar with allowables. Okay. Yes.
Now, for specific materials, do they generally set the allowable stress at a certain percentage of the stress that that material will take
Yeah, I mean, generally, there's what he asks is, will they set this at some percentage of the maximum or the ultimate? The answer is yeah, they will. Some of that's judgment-wise. I mean, some...
It's not like they say for steel, we're going to put it at 80%, whatever the maximum would be. It's generally across the board.
Yeah, in the old steel specifications, they did that. They'd say, like, for bending stress in steel members that were had a small unbraced length, they'd say that the bending stress was 66% of some value. So in the old days, they used to do that. So that's not at all unheard of. Okay, but the allowable is not the maximum. It is not. We call it, typically, a lot of people would call the maximum the ultimate stress. The maximum amount's the ultimate stress. Okay, so the allowable is a scaled down portion, scaled down by some amount, safety factor built in. Okay, but we're not too worried about this right now. All we need to know is our actual stress. As long as it doesn't go over that, we'll be fine. If it goes a little bit over it, will we still be fine? Yeah, probably. But the people that write the codes and stuff say don't go over it. So, how are we going to calculate actual stress? Well, so far, this is how you're going to calculate it. Because all we've talked about is, direct stresses. Tension, compression, bearing, shear, that's the way you're going to calculate it. But wait a second, I thought I said I was talking about design. So, in design, what are we really designing? We're not, we supposedly to design, we know the load that it's supposed to handle. Somebody else is going to give us the allowable stress. So what are we really designing in design? How big the member is supposed to be? If I just look at this side of it, since this is sort of the side that I deal with, what's going to tell me how big the member is? Area. So, what I'm trying to tell you is, if you're really doing design, a lot of times you're designing the area or some function of area. Maybe it's, a little bit later it'll be the moment of inertia or the section modulus. But for right now, think of area, since that's all we're dealing with. Could I rearrange this formula and maybe solve for area? Yeah, sure. I mean, let me just call the allowable stress this. Stress simple, allow. Okay? If I was going to solve for area, maybe like the required area, how about saying P divided by the allowable stress? So that could work, couldn't it? All right. So, quick example. Let's design the size of a square footing. Hold a 50 kip load. Allowable bearing stress underneath the footing. It's 3 kips per square foot. How am I going to do this? Well, again, I just got done telling you, we could take that allowable stress concept and rearrange it so that we can say my required area is equal to load divided by allowable stress. In my case here, I got a 50 kip load. My allowable stress for the bearing for the soil underneath is 3 kips per square foot. So my area that's required is going to be what? 16.67 square feet. Now I said design the size of a square footing, so I guess you could say, well, a footing, if I just took a look at the two sides, if it's square, that means one side's B and the other side's B. So I could say B squared, B times B, right, is equal to 16.67. And then I could take the square root of each side, so B is equal to the square root of 16.67. What's that going to come up with? 4.08. So you might say, hey, maybe I'll do a 4.25 foot by 4.25 foot footing. So we got a 4 foot 3 inch side, a 4 foot 3 inch side, and that will work. That'd be a little bit bigger than I need, but that's all right. Okay. Okay. So you see sort of a design there, simple design. It's using allowable stress. It's not the only philosophy we can use. It's one. Your book will talk about load and resistance factor design. It's probably worth reading that, but again, a little bit on design.